Hello everyone, it's me Amna and I'm back with another video on Amna's Learning Hub. In previous class we were studying about states of matter. We discussed in detail about what are the states, what are these three states, what is a matter, how can we identify that something is a matter, and then we discussed some properties of solids, liquids and gases. In today's video, this is another part of the previous lecture. Today we are going to study kinetic particle theory. As I told you in my previous lecture that kinetic particle theory is the base on which the states of matter are depending on. So today's lecture is about kinetic particle theory. First of all, if I break down this topic, the particle means small atoms or the molecules present in any compound or anything, any substance, right? And kinetic means something is moving. So I told you that when we are discussing the moving particles, then they show different behaviors to us. So scientists observed those behaviors and then they gave us a theory which was known as kinetic particle theory. Before studying the theory in detail, we must know the points, basic points of the theory, that what are the basic points on which the theory is depending on. Number one, if we are talking about particle, that means they must be very small in size. So first point will be particles are discrete and very small in size. Discrete means every particle has its own identity. Like for example, this is a particle, so this is another particle. Every particle is separated from other particle. They are not joined. So they are discrete and they are very small. Number two, they are in random motion. Random motion means, for example, this is a block of any state of matter, solid, liquid, gas. We have anything. We have these particles and particles are constantly colliding with each other, right? This particle will collide with this one, this will collide with this one, and this one with this one. And like this, every particle is in random motion, like they are moving in random direction, in any direction, and then they show us this random movement. Number three is these movements have energy. This is very common thing that we usually observe. If I am hitting with another thing, so that I am getting hurt. So that means there was some energy in me and there was some energy in that thing. So when we both collided with each other, so there was some exchange of energy. Another example is, for example, this is a ball, football or any cricket ball. So when this ball is moving and hitting with another ball, so it will displace this ball. That means there was some energy in this ball and this energy is transmitted into another ball. This is called movement. So whenever we observe movement, there is exchange of energy in that. Is it clear? Kinetic particle theory was based on these three important points. Particles are discrete and very small. Clear by this point? Particles are in random motion, and movements whenever we observe any movement, there is some exchange of energy. So we are done with kinetic particle theory. Now we are going to study effect of kinetic particle theory on changes of states of matter. We know three different states: solids, liquids and gases, and all these three states are interconvertible. They can convert from one form to another form. And in this conversion, the main thing which helps us or which makes us understand is kinetic particle theory. So we know that there are three states: solid, liquid, and gas. And all these three states are interconvertible into each other. For example, solid is converting into a liquid. And when these interconversions occur, every interconversion has a particular name and has particular arrangement of atoms which changes with time. So we have solids, we have liquids, and we have gases. Solid is converting into liquid. For example, ice cubes, they are solid. They are converting into liquid water. So this process is known as melting. Then liquid is converting into gas. For example, we are converting water into water vapors. So this is known as boiling. And it's also known as evaporation. These changes can be reversed as well. For example, gas is converting into liquid. So when a gas is converting into liquid, this process is known as condensation. And when liquid is converting into solid, for example, the water is converting into ice cubes. So this conversion of liquid into solid is known as freezing. We have two more steps that usually occur, which is conversion of solid directly into gas. When a solid is directly converting into gas, this process is known as sublimation. And when a gas is directly converting into solid, this process is known as precipitation. So these are 6 changes, interconversion of states, in which kinetic particle theory is helping. If you recall kinetic particle theory, so we discussed there are particles which are discrete and small in size. They're always in motion, so they have some spaces. So if we apply that whole concept here, so when I am talking about solid is converting into liquid, so I am showing you some arrangement here. For example, this is an arrow. If I talk about arrangement of particles in solids, so particles in solids are tightly packed. So this point where the molecules are tightly packed, this is showing us a solid. So solid is when converting into liquid. So after some time, these particles will get some spaces in them. So the point where there are some spaces is known as liquid state. So when this liquid is converting into gas, I told you that the gases have so many spaces in them. It has the motion is quite random and the spaces are quite the molecules are quite far from each other. So now if I draw the diagram like this, where there are very small number of molecules and they are far from each other, so this is showing us that this is a gas. So this is called conversion of state. One state is converting into another, and kinetic particle theory is involved because particles arrangements show us that the particular state is present. Here the particles was close to each other, so we assume that this is a solid. Then there are some spaces in particles, this is liquid. And when there are so many spaces between the particles, this state is known as gas. The whole process will be reversed in the other case. If the molecules have more spaces, that means it is a gas. Like if we observe it in this way now the molecules coming close to each other, but there are some spaces. That means this is the liquid. And the last one, where the spaces are quite negligible, where the spaces are very low, this is called solid. So the whole process is understood by kinetic particle theory. I hope this point is clear to all of you. After this, I am going to tell you a very important point, the third point of kinetic particle theory that I explained before this: movement and energy, the relationship of movement and energy. So I am going to explain that point here in this diagram again. So when the molecules are quite close to each other, they have more energy stored in it, and the molecules are trying to strike each other, but they cannot strike with so much force because the molecules are very close to each other, they are tightly packed. So when they got some energy and they started hitting each other with more energy, so that energy caused the other molecules, the closer molecules, to go far from each other. So when they got energy, they are constantly hitting each other, they created some space, and that solid is converting into a liquid. Again, when they are striking with more energy, so energy is absorbing in this whole process. For example, here the molecules are tightly packed, so it is absorbing some energy. After absorbing energy, the movement was very high because initially they were showing very less movement. So when I provided energy, so now the molecules are hitting each other with the more energy. So when they are hitting with each other with the more energy, they will be converting into a liquid where the particles are now quite far from each other. Again, energy will be absorbed and it is converting into a gas where the molecules are very far from each other. So in this whole process, when the solid is converting into liquid and the liquid is converting into a gas, or the solid is converting into a gas, this process is energy gaining. Energy is absorbed here. And the process in which gas is converting into liquid and liquid is converting into solid and gas is converting into solid, this is energy releasing. The molecules which have excessive energy, that will be released, and when the energy will be released, the movement will be slowed down, and when the movement will be slowed down, the molecules will start coming close to each other, and when the molecules coming close to each other, states will be changing inversely. Clear this point? Now I will shortlist the processes which are energy gaining and the processes which are energy losing processes. So if I talk about solid to liquid and then liquid to gas and then solid to gas. First we will write down the names of these processes, then we will tell whether it is energy gaining or energy losing, energy is absorbed or energy is released. So solid to liquid is known as melting, liquid to gas is known as boiling or evaporation, and solid to gas is known as sublimation. So all these three processes are energy absorbing. Now, if we talk about gas to solid, if I talk about gas to liquid and liquid to solid. Names of processes will be gas to solid is precipitation. Gas to liquid is condensation. And liquid to solid is freezing. So all these three processes are energy releasing. I hope these six changes in states and their names and the concept of energy and the concept of particle, that is particle theory, of kinetic particle theory, I think this should be clear by here. Now there won't be any confusion how the states are converting into each other, what are the names of these processes, and what is the basic idea between among these conversions, and how kinetic particle theory is helping in this. At the end of the video, I will attach some questions from the past papers which will help you to understand what type of questions will come in the paper and how you will tackle it. The concept, the idea that I gave you, if you are writing it in your answer with the right keywords, with these words and the processes and the chemical words, the actual words, you will get full marks. I guarantee you this. So I hope all these processes and their names and the energy changes and the kinetic particle theory and effect of kinetic particle theory is clear to you all here.
Here are some reinforcement questions that I'm attaching from the topics that we discussed, and hopefully you will be able to solve them. And in next video I will try to answer these questions as well. I am also attaching some questions from P1 which is MCQ based. So good luck and solve the questions.